Today we'll be looking at the coordinate plane and how to put shapes in there, specifically triangles, in order to determine distances. So first of all, go ahead and title your notes coordinate plane. An example that I wanted to look at was place a 2 unit by 6 unit rectangle in a coordinate plane. So all you're going to do here is you're going to determine the best place to put that shape. So there's two different ways that you can put a shape in the coordinate plane and make it really useful. And what you want to focus on is using the axis, the y-axis and the x-axis, and the origin. The reason why, you have this 0, 0 here, and when you plug that in for distance formula, that gives you some nice numbers. And you have a 0 here and over there. So that really works out if you snug your shape right to the origin and that axis. Another way to do it is over here where you put it right in the middle. So you split it down the middle with the y-axis bisecting it, and that once again gives you some zeros to work with, and that gives your distances. It's just easier to find distances when you are using those zeros. And you also have opposite numbers, so -3 and +3 would cancel out in your distance formula, so give you 0. So whenever you position your shapes, make sure you put them near the origin, like using the origin and the axis. So let's apply it to an example. It says a right triangle has legs of 5 units and 12 units. Place the triangle in a coordinate plane. Label the coordinates of the vertices and find the length of the hypotenuse. I already wrote my notes on here. They haven't given us our hypotenuse yet, but I just wrote it in after I did the problem. So I put my triangle where I had one vertice hit the origin, and then I had it just 12 units out and 5 units up, and then I connected the hypotenuse. And I needed to determine the distance from this point to the origin to get my hypotenuse. Well, I can use the distance formula doing that. So we know that we have our x values, which are 12 and 0, and we have our y values, which are 5 and 0. So we just plug them into the distance formula, and because we had zeros in there, it makes it really nice, because you're just doing 12 squared and 5 squared, which gives us 169, and the square root of that is 13, and you get your distance. Yeah, you could be doing